Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organizations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello everybody and welcome to today's episode of the Space Industry Podcast by satsearch. I'm joined today by Ian Cinnamon, who's CEO and co-founder of Apex, based in the US in Los Angeles. Now, Apex is a satellite manufacturer that has focused on the rapid development in the space industry, and that's the topic that we're going to dive into today. Rapid satellite development, but hopefully touching on various issues, various aspects of this with application to space systems in general. Ian, thank you very much for being here with us today. I think it would be great if we could set the scene for this discussion by giving the listeners a bit of an overview of your background and the founding of Apex.
Absolutely. Howell, it's great to be here. Really appreciate you having me. To set the stage a little bit, maybe it's helpful to really define what Apex is and what Apex is not. So at its core, Apex is a satellite bus manufacturing company. So satellite bus, also known in the industry as a platform, spacecraft platform, etc., effectively the core set of components that are required to let any payload function and actually do its job in space. So think of it as the metal structure, the solar panels, the subcomponents, all things that I'm sure all the listeners on this show know very well. And something that's interesting about Apex, which I think my background will shed a little bit of light into, is we really see ourselves as a supplier of these platforms to as much of the market as possible. So we reject the idea of saying, hey, we want to go build a custom, bespoke, perfect satellite bus for each and every payload. And instead we say, if we want to be a major supplier of these platforms, we need to manufacture them at scale. And what that means is we want to be in a position where we're not re-engineering it every single time. So we have to define what the product is or the set of different products and then build it. And so that it's something that people have talked about for a really long time. I don't think there's anything new there. Our hypothesis is we are bringing this right skills together to be able to actually achieve that. So to give you a little bit of color on that, I could briefly give you some insight into my background. So I grew up here in Los Angeles. I always loved the aerospace industry. So my fondest memories as a young child were driving out early in the morning to the middle of the desert with my dad and launching model rockets with homemade engines out of black powder I had convince my parents to let me buy at the gun store. So I love the idea of aerospace. Have always thought it was something that was just really the way of humanity exploring beyond where we've been for the last many centuries. And I ended up going off to college and thinking, great, I love this world. Let me go study aeroastro. And I'll be honest, I got to college and I shied away from it. And a lot of the reason was many of my peers who were studying aeroastro ended up explaining that there were really a couple career paths that you could go in. You could go down and you could work for either the government or a large prime or an organization like NASA. And I knew if I went down one of those roads, I would last maybe one day and my personality would not be very compatible with those types of environments and they'd fire me immediately. Exactly. I'd try. Or I could go work for this fintech billionaire who is blowing up rockets named Elon. And at the time I was like, oh, that sounds crazy. Why would I go do that? That one might've been a mistake, but shied away from the industry. And I ended up actually, and I'm forever grateful for this, moving out to San Francisco and pursuing a very, what I would like to call typical Silicon Valley career, where I had the opportunity to do things like go through Y Combinator, start a company, have a successful couple exits, etc., and really understood what it was to build a software company, understood what it was to build a scalable product, really understood what it was to focus on a real business with real unit economics and real margins. So it took me many years, but when I finally came back to the world of aerospace and realized there was a huge gap in the market for satellite buses, I took all of that knowledge that I had from my time in Silicon Valley focused on building real technology products, not just, some engineering services, and said, why don't we marry the two together? Let's treat satellite buses like a real product where we're not going to go do bespoke engineering or customization. Instead, we'll tell our customers, hey, look, we have a few different options and pick the option that you like. And if you don't like it, you can go with someone else. But we think you will because we're able to get it to you much faster for very transparent pricing. And it's flown many times before. It'll work. And that was really the thesis for Apex was, could we take that productized mindset and apply it to satellite buses, which let us deliver on the premise of building them at scale?
Fantastic. Yeah, I think that makes a lot of sense. It's very interesting to understand the arc of your career there. People comment on the way the SpaceX approaches things, that it is treating hardware as software sometimes. I can see that mirrors a little bit of your experience. And great. I fully understand the desire to approach the market in this way. And I'm believing, quite rightly, I think that there is a gap in the market at this level for the buses, for the platforms. But this is space and things are difficult. And on March 4th, your first bus was launched, I believe, on Transporter 10. And I understand the satellite went from a paper design to the finished system in just 12 months, delivering on that promise of speed that you just mentioned. But what were the most sort of complex engineering problems to overcome in developing this technology for speed?
I will say, just to highlight on what you just said, yes, the satellite launched just over a week ago now. Today's March 12th, so we'll see when this actually airs. But as of today, I launched just over a week ago. And you're right, it was 12 months from clean sheet design to launch. The thing, though, that I think is important, especially given your question around the challenges that were critical to overcome, was the goal here was not to put a satellite in orbit. The goal was to put our very first product in orbit. So there's a distinction there, right? Because if you're just trying to say, let me put something up in orbit that communicates down and we call it a minimum viable product or a demo or whatever it may be, that is, I would argue, an easier engineering challenge and an easier supply chain challenge, an easier technical challenge than what we did, which was we said, we are going to survey the market. We're going to define our first product. We're going to go build our first product. And we're going to go take the first one of those off the production line and fly that. So this was not a MVP or some experiment. This was truly the first production spacecraft. And I think that's an important distinction because, look, people put satellites up very quickly. The thing that I believe is the most impressive about what we've done is we've taken a production vehicle of which we have an active production line you can't see, but right to my left over here in our clean room and our facilities where we're building more of the exact same one. And that honestly was the biggest part of the challenge to overcome, right? It wasn't about can we put one in space? It was about how do we build this with a scalable architecture? How do we think about the design for manufacturing challenges? Where from the very beginning, we're thinking about not just what parts can we get, but what parts can we get when we're building these at scale? How do we swap these parts in and out? How do we focus on the software side to make it all interoperable? And I would highlight those two elements, design for manufacturing and the software side, as really the core technology challenges that we had to overcome. And then I would say the other area that is less on the technology side and more on the operation side comes down to supply chain, right? How are we able to not just procure 4 reaction wheels and 2 star trackers and whatever else we may need, but how do we find vendors that will be able to support us, not just with the first one and the second one, but with the 5th one and the 10th one and the 100th one, and scale with us as we grow, yet be able to move at our price point and our speed. And that was a massive challenge that we were able to overcome.
Fantastic. Yeah, it makes a lot of sense. Facilitating the supply chain problems that you mentioned is our bread and butter here at satsearch. And you do come up with across these problems a lot of the time. So it's very interesting that you were able to solve for all these issues while you're focusing on, as you say, the development of your first product. I think that's a really good way of approaching it. It's a very commercial way of approaching it. And essentially, that's how companies should be operating if you're not in the mindset of bespoke development for specific mission programs, for large-scale procurement ultimately from the government or defense or whatever it is. I think this is really interesting. So in that, I think one of the specific issues would be your build versus buy decisions. and also how the supply chain itself is actually organized. And these are two things that companies have to grapple with all the time. What do we buy? What do we procure? What do we build in-house? And then for the things that we are purchasing, how are we actually organizing? I wondered if you could, touch on how you were able to solve for both of those issues or answer those questions while also enabling rapid production.
One of the major pieces that let us achieve this honestly comes down to my co-founder, Max. So Max Benassi, he spent the bulk of his career at SpaceX, and he was effectively the design for manufacturing, scaled manufacturing guy. So Elon would come to him and say, hey, we have this one part. We need to figure out how to make one a month or one a week or one a day or whatever it was, depending on the subassembly, the subcomponent, et cetera. And Max's job was to say, okay, let me figure out what engineering changes we need to make this more manufacturable. Let me figure out what subsystems or subcomponents we're relying on a supply chain from and figure out if those vendors can actually deliver at the cadence that we need. If not, let me figure out how to swap it out, or let me help them get up to speed, and so on. So Max, and that's why Max and I think are such a great co-founding team. I come from that software product mindset. He comes from the hardware supply chain design for manufacturing mindset, and you pair the two of them together. And I truly believe you unlock something very unique and very special, which is Apex. So the mindset that he instilled very early on at the company was, we don't just say, okay, great, let's find a vendor to go work with and go pick them. What we assess every single vendor on is three key criteria. So we look at what is the price, right? That's obviously a big factor. What is the reliability? What's the TRL level? But not just is it TRL 9, but have they had in-space anomalies or their failures or their non-conformance reports or NCRs that we need to look into, et cetera. And then finally, what is the lead time? But it's not just what is the lead time for unit of one. What we'll do from the very beginning is we'll work with our suppliers to project out and say, hey, look, we have a supply chain, a production line right now where we are building 1 satellite last year, 5 this year, 20 the year after, and scaling from there. Show me how you can not just deliver enough for 1 satellite bus today, but how you can deliver for this year, next year, et cetera. And one thing that we very quickly realize is many suppliers are able to do very well in lower quantities, but they break at higher quantities. And many suppliers are unable to do lower quantities, but they thrive in higher quantities. So what that means is from the very beginning, we had to architect our system to use an interoperable set of subsystems and subcomponents where we could swap in and out different components as our production line begins to ramp up and move out of LRIP or low rate initial production into higher volume production. And being able to scalably swap in and out those subsystems and those subcomponents is one of the key things that enables us to move at the pace that we do. And of course, that comes down to the right supply chain mindset, the right design for manufacturing mindset where we're interoperable, and then the right software mindset as well. All three of those things have to come together.
Yeah, absolutely. That's really interesting. I think a lot of this comes down to transparency and trust, because it was very interesting that you said that you would challenge those, not challenge, request of those suppliers whether they were able to scale up, but show you, that's the words you used, to show you that they were able to meet those higher volumes. So there is trust, but it's trust but verify. How are you actually going to do it? Not just could you handle a big order next year? Most people will say, yeah, of course I can. I've just come back from a conference. If I offered a big order to all of the companies there, 90% would say, yeah, of course we'll do that for you in a year's time. But actually show you how to do it, I think, is a key step forward and shows the professional approach that you're taking for your supply chain. So that's really interesting. And obviously this has required a lot of conversations with your tier 2 and tier 3 suppliers, if indeed you use that terminology. And there's a people element in there as well. If you're having to swap suppliers for certain components because they can't meet the timescales that you either have or that you're expecting to have, or the reliability isn't quite there, or you're gathering new data about the performance, whatever it is. And in space, there's a whole myriad of factors that can come into play in the supplier customer relationship that can affect things. So you've touched on the way that you would assess the suppliers. Have there been any issues other issues that you've had to overcome in developing this approach?
Absolutely. So what I will say is one thing that you might find interesting is how we actually work with those suppliers to project out what those numbers look like and to effectively ensure that just because somebody says, hey, look, I can hit those targets, can they actually? And I would say that any good salesperson, if you go to them and you say, hey, Owl, instead of one of these components, I need 100. Can you hit that? There's no way you're going to say, no, go find someone else. You're going to say yes. And then you scramble in the background to do it. So the way that we see it is we believe that trust is something that you need to earn, not that is just given. And it's something that's a two-way street, right? For us to trust somebody, it means that inherently they need to trust us. That is very important. It has to be bidirectional. So what we do is we actually will invite our suppliers to come, or prospective suppliers to come visit us. And we say, come do a tour, come visit our 50,000 square foot facility and envision how your components are going to fit on these inventory shelves. And it shows that we're real and we're serious and we need to buy and we have the capability of buying that kind of inventory. But then it goes the other way. We will send our team out to go visit those suppliers. And we'll show up, and we might show up unannounced. We might show up planned. We might do a little bit of both. And we'll say, show us your line. Show us how you're producing at scale. Show us where we're going to sit on your inventory racks. Show us exactly how this comes together. And we'll be upfront with our suppliers that we're going to go do that, but that ensures that they're actually following through. And I will say, our mindset is not a traditional aerospace supply chain mindset. And the reason for that is a typical production line like what we're doing is not a typical aerospace environment, right? That is not typically done. In fact, a lot of what we do stems from automotive engineering. And one of the big philosophies we've had as a company from the very beginning is we believe in hiring people from the space industry, both traditional and non-traditional space industry, like newer companies and more traditional ones. But I'm also a huge believer in bringing together a team that stems from a non-space background. For example, the leader of our supply chain team, he actually comes from Toyota and Rivian. He comes from a pure automotive background where he's used to doing this with suppliers. This is, for him, this is a walk in the park because it's lower quantities than he's used to doing. So we really try to bring that new mindset in to help work with those suppliers.
That's really interesting. Yeah, it's a two-way street. So you're showing the suppliers what you're expecting of them, but you're also, like you say, inviting them to your facility. And then it's pretty tough for a supplier to then turn around and say, no, you can't come and visit our facility after they've seen you.
Exactly.
Yeah, it makes a lot of sense. And I think, obviously, it's an approach that is working for you guys with the approaching this as a product line. And as you say, if you have someone ex-Toyota used to whatever, 10,000 cars a month or whatever the figures are, I think, this is a very interesting area. Obviously, much higher value, higher reliability and everything, but lower volume. So you're able to see different sides of the problem. And so now I wanted to touch on the technology that you are developing. We've touched on the working practices, the supply chains that would enable you to create anything, but those systems that you are developing, in space, we are seeing a move towards lots of productized, modular, standardized systems right across the supply chain, right from individual materials and electronic components, and right up to a very complex system such as one of your platforms. But there is still a lot of custom development on the supply side, a lot of companies who offer the bespoke engineering, the custom modeling, whatever it is, and bespoke requirements across use cases on the demand side. So people who are coming to the market with unique demands. And although they're often in applications that maybe have been talked about for a few years, the state of the art for space services that have flown and can provide you with the data or the coverage or the in-orbit services that you require is usually a few years behind the conversation. Sometimes these unique requirements can bring additional limitations, and particularly if they're related to defense, for example, which they can often specify. You use certain tier 2 and tier 3 providers. They'll have to be in your country more than likely, and they'll have to have certain regulatory compliance, etc. And this may not be Apex's core work, obviously, but I wondered what your thoughts were on whether it's possible to create rapid production approaches of the type that you're advocating for and are building that can be adaptable to changing requirements?
It's a really good question. And I would actually take a step back and look at Space Development Agency and what they've done. So if you rewind to the beginning of Space Development Agency, when they announced their proliferated system, PWSA, they made it very clear that from the beginning, optical intersatellite links would be a core part of what they do. An optical intersatellite link, I'm sure most of your listeners know, but effectively think of it as a laser terminal. You have one on each satellite, and when they point at each other and they make contact, you can have very high bandwidth communication between two satellites in orbit using lasers, meaning light, meaning it's very fast, et cetera, et cetera. Now, before Space Development Agency really started pushing for this and making it a core part of their constellation, optical intersatellite links existed, but they were not being produced at the volumes that were required. They were almost more of this niche category. But because Space Development Agency announced this, you saw this massive growth in the OISL, optical intersatellite link, or OISLs as they're sometimes called, industry grow very quickly, where all of the vendors started saying, okay, we're going to now start producing these at scale, and we're going to start producing them to the specifications of Space Development Agency because they wanted to win those contracts. So that meant they started building them for a 5-year lifespan instead of a 7 or longer year lifespan, et cetera. So you could really witness the industry very quickly adapt as they saw this demand growing and this signal growing that there was going to be this, effectively, this need in the market for these systems. Now, so that's a good just example of, I think, how this has happened. Now, the way that we see it at Apex is there is absolutely going to be situations where we run into similar issues, right? For example, on the, let's say, solar panel side, right? There's obviously a shortage of gas cells when it comes to the space-rated solar cells that most people like to use on the market. And a lot of that supply is eaten up. So what that means is, can we work with suppliers that are already out there to ramp up production? And that might mean that we go out to them and we say, here's our forecast of what we need. Can you go scale? Maybe it means we go to them and we say, let's go partner and we'll take some of our capital and we'll do some co-investment with you to ramp up production. And now we have dedicated rights to some of that production line, et cetera. So what I would say is there is a wide amount of possibilities that we see in front of us, and the landscape of what is in the realm of possible is pretty robust. Anything from just projecting out demand to actually collaborating with suppliers to, if we really need to, vertically integrating ourselves and building those subcomponents.
Fantastic. It's very proactive, isn't it? It's a very proactive approach to the supply chain.
I think you have to be, right? If you're building at the scale that we're seeing the demand from our customers, there's no way that you can wait around and say, oh, I hope this comes together. And I will say one major part of it, and I think an advantage that we have, is we will order parts from suppliers before we have contracts from our customers. So we will project out our customer demand before they sign with us. And we'll go ahead and we'll say, okay, great. We know that we need to go build 1 or 50 or 500 or 2 or whatever the number is, Ares class spacecraft this year, or Nova class or Comet class, et cetera. And we'll go ahead and we'll pre-purchase the inventory, right? We're not going to wait for that contract to come in, because if we do, everything is too slow. Our production line's not able to move at the pace we want it to move at. We have to be in a position where we are purchasing ahead of time and projecting out for that demand.
Yeah, absolutely. And as you say, that requires those pre-existing relationships with suppliers, that trust, but that verified capability that on both sides. A really good way of looking at it, and taking the risk as well. Essentially, you're able to take the risk to purchase before you have the money in the bank from the orders, potentially.
That's exactly right. So we do take on that risk. And the reason that we're able to do that, and part of the reason that historically in this industry, this almost never happens, is we are not building a bespoke product. So if you came to me and you said, Ian, I have this crazy payload, go build me a bus perfect for that, I would then go think, okay, what subcomponents are going to meet your exact specs? And I'd go survey the market. But because I go back to what we opened our conversation with, we are building a product and we're building many of the same product over and over again. What that means is we don't need to know what the customer payload is to go ahead and start building what we know the customers are going to want, because we predefine that. We know the different configuration packages that let a customer get exactly what they need, but it's all based on the same product. So that lets us actually buy those components ahead of time, because we know, hey, look, let's say this customer falls through and this doesn't happen. That's okay. There's others that are going to go buy this, and they're going to go buy the same base model, maybe with a different configuration package, but that we built it to be able to be flexible in that regard.
Yeah, absolutely. Yeah, makes total sense. And as you say, it's how many other terrestrial businesses operate, but it's just far rarer in space. So it's very interesting to see you working in this way. And
the thesis of the company is that the timing is perfect right now. Launch is no longer the bottleneck. Launch is becoming more and more frequent. Costs are coming down, which means the new bottleneck is now on the satellite platform side, or the satellite bus. The industry is not moving to saying, I want a perfect, exquisite system. They're saying, I want more. I want attritable. I want resilience through attritable nature. I want more and more of these small sats and these spacecraft. And that is what we're doing. And as the launch industry changes and we get bigger and bigger vehicles, we are already working on much larger vehicles that will still allow for that flat pack design. That's ideal for those customers, but that is how we are scaling. And we're very proud to be in the position that we're in.
Brilliant. I was going to ask you as the next question what the next steps are for Apex. You obviously mentioned pretty much the overview there, but yeah, maybe if you could drill down into specifics. You have the mission up on the Transporter 10. What's next? What's the next mission? What's the next, if you can indeed talk about it?
Absolutely. So for the first mission that we've already launched, we were so fortunate that within seconds from separation from the Falcon 9 rocket, we were immediately in contact with the satellite. We had confirmation that within 10 minutes from separation, the solar panels autonomously deployed. It acquired the sun's location. It began pointing at the sun, charging the battery, and we, within hours, had bidirectional S-band communication. So we're very proud that worked so well. Now, on that first mission, we do have customer payloads, right? I'm not allowed to talk about who those customers are, but we have major defense customer payloads on there. And as we wrap up commissioning in the coming weeks, we'll be handing the spacecraft over to them to be able to go ahead and use the spacecraft for what they need it for. Their payloads require several months of operation in orbit before we get the spacecraft back, and it becomes effectively a in-space software testbed for us. So we're very excited for the satellite to be at that position where we're able to really use it for those R&D purposes. Now, what that means is, in parallel with continuing to run this first mission, our sales and our production line never really slowed down. So we're building many more of the Ares spacecraft this year. There's one in the clean room right now being built. We have parts for many more on the shelf right behind that. I'm sitting right now in our current facility, which is where the company started about a year ago. But later this year, we'll be moving into our new 50,000 square foot facility about 10 minutes from here that will really let us be able to scale production away from saying, let's go build one at a time, to be able to really build up to over 100 per year. Now, as we build more and more spacecraft, the key is twofold. So one is increasing the number of configuration packages that we have for the Ares vehicle. So that means being able to not just offer what's on our website, but add more things like high rate downlink, be able to add additional GNC packages, et cetera, that really expand the breadth of customer missions for our ESPA class vehicle, which is Ares. Second is going to be introducing new models. So we're already beginning the engineering work on our two next satellite bus products, which are Nova. Nova is a larger vehicle that will, think of it as effectively an ESPA Grande vehicle that will be a great fit for Constellation customers. And then we have Comet. And Comet is exciting because Comet is a fundamentally different architecture. It's a much larger vehicle. It's about 3 meters by 3 meters, intended to be a flat pack design and really an ideal fit for communications customers, whether that's on the government side or the commercial side, where they're looking to fill up an entire rocket fairing, or eventually it might be a Falcon 9, eventually a Starship, with up to 16 of these satellite buses at the same time, really being able to deploy their constellation at scale. So we're very excited that we're getting tremendous inbound interest on not just Ares, but on Nova and Comet as well. And later this year, beginning to really scale up the engineering work on all 3 of those vehicles to be able to hit the customer demand that we're seeing.
Brilliant. Obviously, best of luck in all of this work and in the opening the new facility, scaling up the production and adding these additional models and configurations. It all sounds like you're on a really interesting path, and best of luck with all of it. I think almost ready to wrap up. I just had one last question, which I ask a variation of this to pretty much all of our guests. And feel free to talk about your work, but also areas of the industry that interest you. I was wondering what you are most excited about in the space industry in, say, the next 10 years. If you think that's a sensible time frame. Sometimes people go, not much, but 20 years, I can tell you what I'm really excited about. So feel free to adjust the number.
No, so 10 years I think is a great number. So the way that I see the market right now is there's obviously a tremendous amount of interest around the space economy for Earth, right? So I would argue most of that comes from the defense side, US, international, all over the world. And then we have some commercial applications as well, right? We've obviously Starlink has proven out the communications market. We have the original in-space communications customers like the EchoStars, the Intelsats, the Viasats, the Eutelsats, the Inmarsats of the world, et cetera, that have amazing businesses. We're seeing some business traction on the Earth observation side as well. But what I'm really excited for a decade down the line is twofold. So first, there are great businesses today that are in their infancy that I would argue are almost really more like science projects, where they're talking about doing things, whether it be asteroid mining or kind of extracting resources from the moon and so on. And seeing all those in the next decade, some will work, some won't, but seeing them shift from these experiments into real sustainable businesses. I think that is something that is going to be tremendous. And I am so excited for that. The second area that I'm really excited for over the next decade is I really believe that everything that we've done, all the satellites that are orbiting Earth right now, are going to have to be replicated for so many different planetary bodies, whether it be the moon, Mars, and beyond. And seeing the economy flourish and prosper, not just on Earth, but for all of these future areas that humanity will explore, getting us a communications infrastructure on the moon, on Mars, getting us the equivalent of Earth observation, but moon observation, Mars observation, et cetera, and adding so much more. I am incredibly excited to see that come together. And I really think over the next decade, we'll start to see both of those elements shift away from, hey, this is an idea, it might be a science project, into these are real businesses. And my hope is that Apex will be the satellite bus supplier for all of those businesses, whether it be the ones today or a decade down the line, as we explore all these new parts of the galaxy. I would love to see Apex be the largest platform supplier out there.
Fantastic. That's a great place to finish on there, Ian. Thank you. Yeah, I really appreciate you sharing all those insights with us and going deep into the supply chain approach and the production approach that you're taking. This isn't the typical space podcast. This is a podcast for engineers and mission designers out there, your potential customers, of course. And I think they'll really appreciate understanding how you're working with suppliers and how a company that is building a real commercial brand and that is investing heavily into this area is approaching the supply chain and the expectations that you have and the requirements that you have, but more importantly, the reason why, the rationale behind the approach, I think is very important for people to understand. And then obviously you've explained the opportunities that are there for those building missions and those end users and customers. And yeah, would just thank you very much. Would really appreciate what you've shared with us today.
It's an honor to be here. Thank you, Hal, for being such a great moderator, and excited to stay close.
Yeah, absolutely. Thank you, Ian. And to all of our listeners out there, thank you too very much for spending time with us today on the Space Industry Podcast. We'll share some information about Apex in the show notes, and you'll be able to follow the company. We'll share the website, etc. You can check out what they're doing, and obviously if you have interest in this area, they're a great place to look, a great company to look at, sorry. And in the meantime, please stay tuned for the next episode of the Space Industry Podcast, where we will be talking to more of the companies who are working on taking us all into orbit in the future. Thank you. Thank you for listening to this episode of the Space Industry by satsearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.